We'll now move on to the applications topic, standard deviation. Standard deviation from a data set, so a collection of values, is a measure of how spread out on average the data points are from the mean value. So what I'm going to try and do is to illustrate this down here by drawing two groups of people. So what we have is group 1, these 4 people here, and group 2, these 4 people here. Now, when you first look at this, you obviously notice a difference between group 1 and 2. Group 1, everyone seems to be of a fairly similar height, whereas group 2, the heights they vary a lot more. What we're looking at when we're looking at standard deviation, say for instance I was to take the heights of these 4 people, add all those heights together and divide by 4, that would give us the mean height, so the average height. Okay, the mean height could be represented, say for instance, I'm going to put a red line where I think roughly for this group of people where the mean height would be. So I would say the mean height would probably be somewhere around here. This would be roughly where the mean of their heights would sit. For the other group, the mean height's going to be slightly different. I would say, just at a rough guess, we'll put the mean height in about here. There's obviously some shorter people in that group, so it's going to drag the average height down. So it's going to be a little bit lower there. Now, if I look at these, what I'm looking at for standard deviation is how far on average the people in these groups differ from the mean. So what I'm looking for, and I'll try and illustrate this with a little green line here, is from the mean line, how far is that first person in group 1, how much do they differ? They differ roughly this amount here. Okay, so if I look at the second person in that group, how much do they differ from the mean? Again, I'll try and put that line in a green pen. So the second person in group 1, they differ approximately this much from the mean, the length of this line from the mean. For the third person, it's only a tiny difference from the mean, so they differ this much from the mean. And lastly, the last person probably differs most from the mean. But if I take these as a whole and was to work out the average length of these lines, that would give me a rough idea of the standard deviation. So, because these lines on average are quite short, that means there's a small standard deviation. There's a tightly clustered or consistent set of values. All of these people are roughly the same height. In other words, they all differ from the mean by a very small amount. A small standard deviation means, on average, very little difference from the mean height. If I was to look at group 2 though and do the same thing, where I put in lines to represent the difference between the mean height and each individual's height, you can see at the first person in group 2, the difference between the mean height and the first person's height is kind of represented by this length here. And I can continue to go through that for person 2 in that group. The difference between their height and the mean is represented here. The third person, the difference between their height and the mean is represented by this line here. And lastly, the last person, probably is the furthest away from the mean. The difference between their height and the mean is represented by this line here. What you'll notice about these lines is, on average, they're much longer than these lines. That makes sense because, on average, these heights vary a lot more. So, this would have a large standard deviation, and it represents a less consistent or more varied set of values. The heights here vary much more, which means on average the individuals within the group, their height differs more on average from the mean. So this would represent a higher standard deviation, while this group would represent a lower standard deviation. We'll now go on and look at how we'd actually calculate the standard deviation. If you have the National 5 formula sheet, you'll notice the formula for standard deviation is given, but it's given as two separate formulas. This one here is the second of those two formulas, and this is the one we'll probably use most of the time, if not all of the time. It has some new notation. This little symbol here is called sigma, and what it means is it means the sum of the values. So if I see sigma in front of x squared, it means the sum of all the x squared values. So, as I said, this formula will be given on the formula sheet, so you don't need to memorize it. We just need to know how to use it, which I'll show you in the next few examples. N is the number of values in the data set. So if, say for instance I take a data set, make up a quick data set. So we'll call our data set X, and it'll have values 1, 2, 5, 6 in it. So in this case, n is the number of values in the data set. So this data set has 1, 2, 3, 4 values. So in this formula, n would simply be 4. We then move on to this thing here. This is called sigma x. Remember, it means the sum of x. So it means the sum of all the x values here. Now, the sum of these numbers, let's see, 1, 3, 8, 14. If I put a total line underneath that, that comes to a total of 14. Therefore, sigma x here, meaning the sum of all the x values in this case would be 14. So this sigma x would be 14. Sigma x squared, which means the sum of all the x squareds, well, I know what the x values are. To find the sum of the x squares, I would have to actually square all these values. So what I might do is I might take another column there and call it x squared and square each of these 4 values that are sitting here. So 1 squared is 1 times 1 is 1, 2 squared is 4, 5 squared is 25, and 6 squared is 36. So what I'm looking for here when I'm asked for sigma x squared, the sum of the x squareds, is to add all the x squared values together. Now this is going to give me 1, 5, 30, 66. So in this case, if I was asked for sigma x squared, or the sum of x squared, that would be 66. For the questions we'll do, what you'll probably notice when you do past paper questions and things, it's very common to be asked for the mean and the standard deviation in the same question. So just be aware of that. When you see standard deviation, make sure they're not asking for the mean as well, because quite often these two parts will go together. So in this example, we're given the ages of a 5-a-side football team, 18, 21, 23, 36 and 28, and we're asked to do 2 things. We're asked to calculate the mean and the standard deviation. Now, there's a bit of crossover in the working between the 2 of those, so what we'll do is we'll start off by creating a table with our values herein. So up at the top of that table, we're going to put an x, and underneath it we're going to list the values vertically, so 18, 21, 23, 36, 28, and we're going to draw a line down here and a line across, because we don't just need x for standard deviation, we also need to put in x squared. What we'll then do is we will start to square each of these values here. So 18 squared, so on your calculator that's just 18 squared, or 18 times 18, that's 324. 21 squared is 441. 23 squared is 529. And 36 squared is 1296. 28 squared is 784. What I then need to do is calculate the totals of each of these. So going down the x column over here, start by adding all of those values together. You can do that on a calculator in most questions. So we've got there a total of 126. Now what that gives us here, this is the sum of all of the x values. So the first step in this question is I need to calculate what the sum of all the x values is. So over at the side of this table, I can write the sum of x is equal to 126. That's basically the sum of all the x values, all of the x values added together. What I'm then going to do is find the sum of all the x squared values. These are all my x squared values down here, so I'm going to again type them into a calculator, add them all together and put the total at the bottom there. So the total of those comes to 3,374, and that allows me up at the side again just to write that out. The sum of all the x squareds is 3374. Now if you look at the question here, the second step is to find the mean. Up in the question we're asked to calculate the mean. To calculate the mean, as you already know, is we add all of the values together, then divide by how many numbers are there. So when I write out mean equals and add all the numbers together, remember that's already been done, so we've already added all the values together to get 126, so that can go up at the top here, 126, divided by how many numbers were in the list, and we have 5 numbers in our list there. So 126 divided by 5 gives us a mean of 25.2. The next step here is to write out the formula for standard deviation now that we've calculated the mean, and we'll do that over here. So we're just going to use the abbreviation S.D for standard deviation, and we'll write out the formula. Remember the second formula on the formula sheet, which is the sum of x squared minus the sum of x all squared divided by n all over n minus 1. Now, we need to be quite careful when filling in this formula. So we'll start with the square root, And the first thing in my formula is the sum of x squared. Now that is this here, sum of x squared, which is 3374. So let's fill that in, 3374. And again, the next part looks similar because it's again the sum of x and there's a squared sign, but these two things are not the same. This time the sum of x is inside a set of brackets and it's the sum of x which is being squared. So the bit inside the brackets is the sum of x. So that's going to be 126 inside the brackets, and that's being squared. Now we don't really need the brackets anymore, but if it helps put them in, we can. So 126 is the sum of x, that's the bit inside the brackets, that's being squared, and then that last part there, just this part here, is then being divided by n. Remember, n is the number of values in the data set, and we have 1, 2, 3, 4, 5 numbers in our data set, so that is being divided by 5. This is all then being divided by n minus 1, so it's all then being divided by 5 minus 1. What I've then got to do is take my time evaluating that. Now, it might be tempting to try and recreate this in your calculator, but obviously there's multiple lines here, there's brackets, there's other things to take into consideration. So what I would recommend you do is just evaluate the top part of the fraction, leaving the square root, leaving the division by 4 or 5 minus 1 here till later. So in other words, all I would want you at this stage to probably type into your calculator is this section here. In other words, don't touch the square root button yet. So when you type that in, what you should end up with is 3374 minus 126 squared divided by 5. Your calculator, if it's a scientific calculator, should take care of the BOD mass part of that for you. And you should end up with 198.8. And you can check that by doing that just now yourself, pausing the video and checking. You get 198.8 in this space. Divided by 5 minus 1, we don't need a calculator for at the bottom here. 5 minus 1 is just 4. So when you do the first calculation here, make sure we're not touching the square root button yet. We're just doing 3,374 minus 126 squared divided by 5. And we end up with this. The next thing I want to do, again, I'm going to leave that square root for the moment. I'm just going to evaluate this fraction. So I'm just going to take the value, which should still be on the screen of my calculator, which is 198.8, and I'm just going to press divided by 4. So take that 198 divided by 4, and that's going to give me 49.7. And again, using the answer function on your calculator, the fact that that 49.7 should still be sitting on your calculator screen at this stage, you're going to press square root of answer, which will give you the square root of 49.7, which is 7.05. Now that means that's our standard deviation for this set of data down here.